In this video, we're going to talk about radian angle measure and connect it back to degree angle measure and learn how to convert back and forth between radian and degrees using a conversion factor. First, let's talk about what radian measure is. Radian measure relates to the length of the arc, the central angle, and the length of the radius. A central angle that has a measure of 1 radian is the angle that forms an arc with the same measure as the radius of the circle. So if we look at this diagram, a single radian will be the angle at which the arc will be equal to the same length as the radius. So this length here and this length here are the same when it's 1 radian. The question is, how many single radians fit in the circle? Well, if every arc is 1 radius, how many radii fit into a circumference? And we already know that. C equals 2 pi r. So how many r's fit is going to be the number 2 pi, or approximately 6.28. So a little over 6 of these radii can fit around the circle. So that means every 360 degrees is going to be equal to 2 pi radians. Or if you simplify that into a fraction, we could change it to pi over 180. Cut both of these numbers in half. And that's your conversion factor. Pi over 180 or 180 over pi, depending on what you're converting from or to. So in looking at a 60-degree angle, it says find the measure of each angle in radians if given in degrees, or degrees if given in radians. This is given in degrees, so we're going to convert it to radians. So we need to get rid of the degree symbol. So 60 degrees over 1. And you have to decide between multiplying by pi over 180 or 180 over pi. You want to cancel out the degrees, so put the 180 degrees on the bottom. And this way you can cross out the degree symbol, and on top will go pi. And that's how you decide if it's pi over 180 or 180 over pi. You got to see what you're going to cancel out by putting whatever's here in the denominator of your conversion factor. So degrees cancel out. You have 60 over 80, which you can simplify to 1 over 3 pi. That'll be in radians. Or you can write it like this, pi over 3 radians. Either way is okay. That's because 360s go into 180. Let's do another one with the degrees to radians. 240 degrees. Again, you want to cancel out degrees, so put the 180 degrees in the bottom and put the pi on top. Common factor here, divide both numbers by 10. You have 24 over 18. Greatest common factor there is going to be a 6. That's 4 for here, and then 3 6s go into 18. So it's going to be 4 pi over 3 radians. And remember, you can write fractions together, or you can write it 4/3 pi radians like that. Either way, it means the exact same thing. Let's try a couple where you're converting from radians to degrees. This says pi over 4 radians. If I want to cancel out radians, I need to put the radians on the bottom and put the degrees on top. So this is where you use 180 over pi. The pi's will now cancel. And now you have 180 divided by 4, which will be 45. And since that's a degree measure, degrees. Let's look at another example over here. 4, we have 3 pi over 5 in radians. I want to cancel out radians, so I'm going to put the radian number on the bottom, pi, and put the degree on top, 180 degrees. Pi's cancel. 3 times 180 over 5. You can simplify the 180 and the 5. 5 goes into 180 36 times. So you guys may have called this cross-canceling. So now you have 3 times 36. That's going to be 108 degrees. So, to recap, every circle has 360 degrees as an arc, or 2 pi radians. And the conversion factor is simplified to either pi over 180 or 180 over pi. You have to decide correctly whether to use pi over 180 or 180 over pi given a certain problem. If you're given degrees, you want to convert to radians. You want to cancel out the degree measure, so put 180 on the bottom. If you're given radians and you want to go to degrees, cancel out the radians in the bottom and put the degrees on top, and therefore you would end up with degrees.